In this video, we will be doing the first algebraic method, which is substitution method. So what is substitution method is in which if you are given equation with x and y, what you do is consider the y in terms of x and then replace the original y with the in terms of x y and get the solution. We might not have understood that clearly, but let us do one question by which we can get it. Here, if you notice, I have x minus y equals 4. Now x minus y equals 4, right? So if I take my y here to the other side, I'm gonna get my x as 4 plus y. If you notice now here, my equation is x equals 4 plus y. Here my x is the same as x, and x is also same as 4x plus y. So they both are basically same. Now in the first, I'm gonna place this 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 thing which I got in terms, oh sorry, this is 4 plus y. So I'm gonna replace x with 4 plus y in the first equation. Now that is going to be, if now I have x plus y as 14. Now if I substitute this 4 plus y in terms of x, I'm gonna get 4 plus y, that's x, and I have a plus y equals 14. So I'm gonna get 4 plus 2y equals 14, right? Now I have a 4 here, so I'll take the 4 to the other side, which will give me 2y 2y equals 4 to the other side and 10. Now if 2 divides 10, I'm going to get my y as 5. After getting y as 5, finding x is not that big problem. So basically I'm going to replace, if I have this equation, I'm going to replace the y with a 5, right? Then what I'm gonna get is I'm gonna get my x, it'll go there, subtract as 9. So basically the things which we need in this question is the values of x and y, which gives our x as 9 and we get our y as 5. Okay, in the next question, this is taken from NCERT as well. So in this question, we are given a little bit of multiplication in these equations as well, but in these equations it's directly plus or minus. So in this, let us take this first equation, right? That is 3x minus y equals 3. Now I'm gonna get my 3x as, now when our y goes to that side, I'm gonna get 3 plus y, and I'm gonna get my x as 3 plus y divided by 3, right? Now I'm gonna replace this value of x, so which is going to give me 9. Okay, and I have 3 plus y by 3, right, by 3, and I have minus 3y equals 9. Now by solving this, I can cut this off, I'll get a 3 here, so I'm gonna get 3 3s are 9, okay, and 3y in minus 3y equals 9. These y's are going to cancel out, and what I'm gonna get is 9 equals 9. Now this is a very weird thing to get. So what this actually means is that y can have infinite solutions. Okay, it can have infinite solutions. Now if y can have infinite solutions, that means that for every infinite solution of any solution of y, will give our x. So this here, when our x cannot be definite. So now if you want to try the other way around, where we find the value of y, so we can do that as well, but that will also give us some equation which will be like, maybe say the number left will be a and I'm going to get equal to a, something like that. If we are not going to get a definite value in this question, because these two lines, if you draw on a graph, you can notice that they are going to be coincident lines and they'll go on forever. So that means it does not have a particular value which is needed. It has infinite solutions. So now one more thing, if you notice this question, in this question, that if we take this, if we take 3 common out of this, okay, I'm gonna be left with 3x minus y equals 9. Now if I divide my 3 there, I'm gonna get 3x minus y equals, now if I do that, I'm gonna get it as 3, right? Now notice one more thing, that these two equations are the same. So if the both equations are the same, they will have infinitely many values. There one more way how we can figure out if it has infinite values is to see if the coefficient of the first, I'll write this thing here, just wait. That's b1 by b2 and c1 by c2. So what is all this is basically, a1 is our this coefficient, the first, this is equation 1, okay, and this is going to be equation 2. Okay, so a is the coefficient of the first, if a coefficient of x. So coefficient of x or y or whichever is in the front. So now if I consider my a as, I mean if I consider the coefficient of x as a, then the coefficient of x in the second equation will also be a. If I consider the coefficient of y to be a, then in the second equation also the coefficient of y will be a. Here I'll consider the coefficient of x to be a. So in the first one I'm gonna get 3, and a2, which is the a of the second equation, which is 9, and 9 here. So this is basically, if you notice, it is 3 by 9, okay. And then I have b1, which is minus 1, right? And then I have my b2 minus 3. Then I have c1 3 here. C is basically the constant term, and c2 is 9. Notice here that if we simplify all this, I'm gonna get my a1 is equal to b1 is equal to c1. So when all of these are equal, it means that it has, first, that it has that it has infinite solutions, okay. And second, that when we draw this on a graph, we will get a coincident line, Coming to the third one, we have 2x plus 4y is 8 and 4x plus 8y is 12. Now let's write the first one in terms of x in terms of y. So I'm going to get 2x equals 8 minus 4y. So I'm going to get my x as 8 minus 4y by 2. Now that's not so good. Minus 4y by 2. To simplify this, we'll take 2 common out of here. I'm going to get 4 minus 2y by 2. So basically now my x, this 2 cancels out, my x is going to be 4 minus 2y. Now let's do one thing. We'll replace this value of x with a different number. I mean with the value of with x in the different equation. So that is going to be 4 times 4 minus 2y plus 8y equals 12. Okay, now 4 4s are 16, and I have minus 8y, and I have a plus 8y, and that equals 12. But my problem here is when these two, they become 0, right? So 16, I get 16 equals 12, which is not even possible, right? So basically this equation does not have a solution. It does not have a solution. That means that when we draw a graph of this equation properly, if we draw a graph, we're gonna get the lines parallel to each other. So if they are parallel, they don't intersect anywhere, right? So though, then I'm not going to have a perfect solution of this. Now also, without doing all this stuff, how we can figure out if they have a solution or not is by seeing that if the coefficient, again as I told in the previous question, that if the coefficients this time they are equal to the second coefficient but are not equal to the third coefficient. Okay, so now let us do one thing. Let us take the coefficient of x as a here, so I'll get 2 by 4. Okay, that is going to be equal to 4 by 8, and I have my c here, so my c here is 8 by 12. Now what I'm gonna do, I'm gonna reduce it to its lowest factors. So that's gonna be 1 and 2, and also 1 and 2, and this is going to be 4. No, not 4, this is going to be 2 and 3. So basically it is obviously true that 1 by 2 is equal to 1 by 2, but it's obviously not equal to 2 by 3. Now if you notice here, we already see that this is satisfying, so that basically means that it does not have a solution. Let's go back to our first question. Here, why we got the solution is because if you notice, these two equations, when we draw the graph of these two equations, they intersect at least some point, right? So now let me take a different, so if I have say, now if I have say these two, right? So here, this for them to be, intersecting or having a solution, it should be that the coefficient that should not be equal to the coefficient of the second one. That's it. And if it is equal to c1 or not equal to c1, it doesn't matter so much because the first two are not equal as well. Okay, now let us see if that this satisfies that thing. So now let us write, I'm going to write it here. Okay, let us write the coefficient of x in the first one, so that's 1, and I have a coefficient of x, again it's 1, and that should not be equal to the coefficient of y, that is b here. So this is the first equation. Okay, and this is the second equation. So in the first equation I have 1, and in the second equation there is a -1. So obviously, if we write these, this is basically 1 is not equal to -1, and that is very obvious. And if these two are not equal, which it satisfies, that means it has a solution.